Hi, this is question 7, or the second mechanics question in this paper. What have we got? We've got 3 forces. We've got an 8 Newton force acting to the left, an 11 Newton force acting downwards, and we've got a 21 Newton force acting at an angle. They tell us a little bit about the angle here. They say that tan alpha is 3/4. Which is, they give this ratio quite a lot. This is quite a specific thing. We can use like a little shortcut for it. I guess the idea with this one, we're going to try and break down the 21 Newton force into a horizontal and vertical component. Not going to go into a lot of detail with this, but hopefully you should be happy that this can be broken down into 21 sine of the angle if you play around with trig a little bit, and this one can be broken down into 21 cos of the angle. Now, I mentioned earlier this 3/4 is a specific ratio. You can consider what we call a 3-4-5 triangle. You might have come across it in what's it called, Pythagoras before. So if you have a triangle where the hypotenuse is 5, the other sides could be 3 or 4. Notice 3 squared plus 4 squared, 9 plus 16 is 25. So it's just what we call a 3-4-5 triangle. And if you take tan here, which is the opposite of the adjacent, you get, well, the opposite is 3, the adjacent is 4. Cool, there we go. So it's part of the 3-4-5 triangle. We can come up with similar expressions for sine here, just by saying, well, sine is worked out by dividing the opposite by the hypotenuse. So it'll be 3 divided by 5, and cos is the adjacent divided by the hypotenuse. The adjacent is 4, so it'll be 4/5. So rather than reversing tan alpha, getting an angle, there might be a loss of accuracy. We can just use the 3/5 and 4/5. Much easier. So in this triangle, I've got 21 over here. This is, oh, nice. This is going to work out as 21 times sine alpha, which is 3/5. This is going to work out as 21 times 4/5. Might try and do this mentally, that's brave, isn't it? So 21 times 3/5 is 63/5, which is 12.6. And down here, is that right? Yeah, I think that's right. And over here, we're going to get a similar thing. I think this one's going to work out as 16.8. Yeah, I feel a bit better about that one. Yeah, that sounds good. Lovely. So let's look at the balance of forces all together. When we look horizontally, we've got the 8 Newton force, which is going left, and we've got 21 cos alpha going that way. 21 cos alpha was this bit here that I've just underlined. 16.8 newtons going that way. So if I take that into account, the result of these things together, this one's bigger, 16.8. 16.8 take away 8 is 8.8. So the resultant that way is 8.8 newtons to the right. Looking at the vertical, we've got an 11 Newton force acting downwards. We've got 12.6 newtons acting upwards. So the vertical force is slightly more. 12.6 take away 11 is 1.6. Lovely. So I've got the individual resultants, 8.8 that way, 1.6 that way. I'm not quite done because it does ask about the magnitude of that force. So I'm going to have to chuck this into Pythagoras. and I'm probably going to actually need to work this out properly using a calculator now. So let's chuck it in here. We're going to get 8.8 squared plus 1.6 squared. Bear with me. Where's the calculator? Hey, there it is, right. So square root 8.8 squared plus 1.6 squared. Let's square root that to see what we get. 8.94. Cool, right, let's jot that down. 8.94. Cool, and that is the magnitude of my resultant. Part A is done. Okay, so for part B, there's a few ways of doing it. I think the easiest way of doing it is to consider the angle. Oopsie. So let's try that again. We'll consider the angle, what angle it would need to have to cancel out the 8 newtons exactly, and then same with the 11. So for horizontal equilibrium, we'd have the 8 newtons this way, and we've got 21, oh, what was it? It was cos, yeah, it was cos, that way. So if they're equal, I can work out what angle I'd need for that. Arc cos, probably should chuck another C there. So let's see what angle I get out from that. Okay, so inverse cos of 8 over 21, so 8 divided by 21. And then the inverse cos of that is 67 degrees. If I run the same thing with vertical equilibrium, we're going to get an 11 Newton force going downwards, 21 sine going upwards. And I'll see what angle I get out here. So 11 over 21. Let's inverse sine that. 31 degrees, or 32 degrees to the nearest actually. There we go. Okay, so there's an issue here. In order to get a horizontal balance, you need an angle of 67 degrees. In order to get a vertical balance, you need an angle of 32 degrees. Those angles aren't the same, they don't match up. So you're not going to be able to achieve horizontal equilibrium and vertical equilibrium at the same time. Can I squeeze this in? Probably not. Can't have them at the same time. They're different values of alpha. Lovely.